This is a video lesson for MP44 domain and range. Domain is a set of x values in a relation, and range is a set of y values in the relation. So it's basically all the possible x values that you could have with your relation or function, and all the possible y values you could have with your relation or function. And a way that you can remember this is by Dr. XY. D goes to the x, and R goes to the y. When you have a set of points here, all you have to do when you list it, okay, if you just say D, and then list the points, or list the x values. And then for range, same thing, list the y values. When you're looking at graphs to determine the domain and range, for the x's, my x values start at -1, and then they continue towards the positives. So I'm starting here and going towards -1. So when I write my domain, I'm going to use set builder notation. I write x such that x is going to be greater than or equal to -1. It also implies that you could have any number greater than -1 and you're good. And then with range, it's the same idea. My range is going to start at -3 and it's going to continue upward. That line is going to continue upward and hit all possible y values. So I write y such that, that's what that line means, y is greater than or equal to -3. I use greater than or equal to because this circle is filled in. If this circle had been like this and gone up, I would have just used greater than or less than. But since it's hitting that point, I use greater than or equal to or less than or equal to. For the next one, looking at my domain, I look at what x values I could have, and you're basically going to be able to have any x value. As you continue onward, you could plug in any x value along this line and you would get a y value out. So your domain in this case is just going to be all real numbers. So you just say x belongs to the real numbers. Again, you could plug in any x value, it'll keep going, it'll hit every single one. And for range, we have a limit for our range. Our range is not going to exceed 1. It's not going to go past that. It's just going to go from 1 downward. So for range, we write y such that y is less than or equal to 1. It's never going to go above 1. For the next one, these are called asymptotes. They're lines that the graph is going to approach but never actually touch. So when I look at my domain, I look at what x values I could have. I could have any x value going this way. Okay, I'm going to get a bunch of x values going that way. And then I could have a bunch of x values going this way. What's going to block me from getting an x value is this line. That's what's going to block me. That's the only x value I can't have. So I'm going to write it as x such that x cannot be 2. Again, I can have any x value except for that asymptote. I can't touch that. And then the same idea will apply for range. As I look at my y values, I can have any y value. It's going to go up, it's going to keep going down, so I can have any y value. Again, what blocks me is this line of y equals 1. I'm not going to be able to touch that line. So that's going to be my range. Y such that y cannot equal 1. I'll leave you to follow these directions to plug into your graph. A couple of things that I'll point out to you when you plug it in. You're going to go to the calc menu. So first you put in your y equals. After that, you're going to hit graph. Then you want to go to the calc menu, so that's second trace, and go to maximum. If the graph opens this way, then you would select minimum instead. It's got a min instead. Calculator needs to have boundaries. Otherwise, it's not going to know where to find the max or min. Sometimes graphs have multiple max or mins. So what it's going to ask you after you hit enter is if you need a left bound. So what you need to do is be on the left side of the maximum. So here's an example. Here's the max. Here I am on the left side. That's just, look at your left hand, that's the left side. So my cursor's on the left, so I would be in good shape to keep going. So after you do that, all you hit is enter as long as your cursor's on the left. Then it will ask right bound, and you have to move your cursor to the right side of the maximum. And the same thing, you would hit enter after that. Then your calculator will ask you this guess thing. I don't have the screen here, but it'll ask you guess. You'll hit enter. You don't have to guess yourself. And it will take you to the screen that has the maximum. When you see something like this, your calculator is using some sort of certain amount of significant figures. If you see something that is this close to 2, you can assume 2, 5 would be your maximum. So our maximum is at 2, 5. So our domain, again, I can plug in any x value, doesn't matter, I can keep going, and I'm going to get x values along here, and you can also look at it as the function. You can plug in any old x value that you want into this equation, you'll get out a y value. So for domain, I just write x such that x belongs to the reals, close it off. For my range, I've got a max and my range. My graph was never going to go above the y value of 5. That's where it stops. So I have y such that y is going to be less than or equal to 5. It will never go above.